Hello, everybody. My name is Doitshman. Very excited to be here. I'm a security research team lead at Kato Networks. Kato is a security company, actually a SASE company. Our goal is to converge both network and security and to deliver this product to organizations, to enterprises around the world, and actually converging both network and security into a single cloud-based platform. Today, we are going to talk about threat intelligence and more specifically, how we build a threat intelligence pipeline and using machine learning feedback during the process. Let's go. So, we are going to talk about several ideas. First, we are going to introduce a bit some key terms about threat intelligence. And later on, we are going to talk about the challenges. As you know, there are many challenges in this process. And the main focus of the presentation is actually to talk about the architecture of our pipeline, how we do it actually in Kato, and also introduce the machine learning feedback, how we use the feedback from the production environment to optimize our process. And finally, we are just going to talk about some case studies and conclusions. So, what is threat intelligence? I guess most of you know threat intelligence. For understanding threat intelligence, we have to talk about three key terms. The first one is IOC, indication of compromise. IOC basically is the most explainable definition for it, any observable item in a relevant environment. I know it's, let's ground it a bit. It actually can be any artifact in the network or in the host that tells us that the host or the network has been potentially compromised. It can be a suspicious domain name, it can be a suspicious IP address or IP ranges, or also a user agent, anything. It can be anything. IOC can be anything that can tell us in some confidence that we have been compromised. And our goal is to collect most of the IOCs in the world and to prevent our customers from accessing network flows that contain these IOCs. But, you know, there are millions and billions of IOCs in the world. We can fetch them one by one. So the next term is threat intelligence feed. Threat intelligence feed actually is a list or aggregation of many IOCs. And the threat intelligence feeds we get from many kind of sources. We can get them for free from, GitHub or some public list in the internet. We can also pay for that. So to vendors that actually do that, actually work in supplying threat intelligence. And the threat intelligence feed is just a list of IOCs. It can be a list of domains, list of IPs, list of URI, anything. And the last key term I want to talk about is TIP, Threat Intelligence Platform. Threat Intelligence Platform, actually, the goal of TIP is to manage multiple feeds. So the first question we can ask is, why do we need a tip if we have already the feeds we get from somewhere? So there are two goals for a tip. The first one is to manage all of this operation. We get these threat intelligence feeds and then we have to deliver them to the production environment. We have to deploy it. We have to have some a cycle for deploying it. So that's the first reason. The other and actually the most important reason is to clear false positives, because these threat intelligence feeds are not holy. We know that many times we have false positives, can be a false positive in domains, IP address, and blocking sending an IOC which is a false positive may cause damage in production because customer will complain and all of these not nice things. So clearing false positives is actually the main goal of a tip. And let's jump to the end. This is our reputation service in Kato. This is a tip in action. What we have here is our main page, very simple. We enter an IOC, a potential IOC, in this case an IP address, and we just want to get a bottom line verdict about what we know about IOC. Is it malicious, suspicious, or unknown? In this case, we got a malicious score, and that's the main goal of the entire process. That is another example from the Kato XDR product. It stands for Extensive Detection and Response. Here we see how the tip we have built are used in production. We actually see an incident that the customer got about CVE exploitation attempt. And what we see in the graph and in the small table is two targets that we found in our tip as malicious. And we see the frequency of requests to these targets. And so this is an example how we can use our tip in a production environment, in incidents we want to report to the customers. Okay, so far we talked about the end goal. Let's go a bit back. Now we want to talk about the challenges, how we build that tip from scratch. So I think the first challenge, the most important one, is the volume of the data. So as I said, we have tens of millions, billions actually of IOCs in the wild. And the first question is how we choose which source to take, how we choose which GitHub page to detect over time. And this is a very hard question we are going to answer. Also, in addition to vendors, to GitHub, we have blogs, we have security forums, we have many sources we may want to scrape and to fetch. So we need to decide. The most difficult thing is how to decide what is best. The second challenge is actually, I call it response time. If we have the best threat intelligence in the world, but our response time is 3 days, it's not so good. We want to publish new IOCs to the wild, to the production environment as soon as possible, because the malwares are not waiting for us. We need to be very responsive with the field. So that's actually the challenge, how to keep track of so many malware and so many malware in the wild. And the third challenge, which I find the most difficult, is how actually we have always the trade-off of false positives and false negatives, and we should put a cutoff somewhere. Too much false negatives, our customers will be at risk. And too many false positives, our customers will hate us because we are spamming them with many blogs and the false alarms. So now we move to talk about the high-level architecture of the tip in Cato. So we have above 250 IOC feeds we get from multiple sources. Some of them are free, some of them are upon a paid license, and we get we get those IOCs list into our tip. The first layer is a filtering layer. If one of these IOC provider finds a google.com as a malicious domain, we must filter it out. We can't deliver it to production because our customers won't be able to access Google. So the first step is actually this filter layer. The next layer is the machine learning model. We'll talk about it later, but this machine learning model, which encompasses many security features and the context features about IOC, finally outputs a bottom line score, as we saw before. Based on this score, we decide if we block this IOC in production or not. And finally, after all the IOCs that we found as malicious are going to the Cato cloud, which is the production environment, and then block customers in real time. Later, after these IOCs are getting to production, we have the back propagation step. We actually get a feedback. Feedback, we'll talk about it, what kinds of feedback we get later. So we talk about many things here, aggregation, data feeds, but I want to make some, except the IOC feeds, which we get from a third party from somewhere in the internet, we have the internal data we are working with in Cato. So this internal data is used most of the times to filter out false positives. So the first data source we are using is the NetFlows data warehouse. We actually in Cato, since we are a SASE company, we see all the network, all the requests of our customers. We have the data of all of the requests of the customers to the internet. And we can understand quite clear how communication to an IOC looks like. Communication to a C2 server most of the time looks a bit different than a communication to a well-known website. And based on this data warehouse, we can understand many insights and things about this IOC, the potential IOC. The next important data source is the popularity. As we know, popularity actually means how popular this potential IOC in the wild. let's say if I will look about google.com, possibly I will see tons of requests to that domain because, it's very popular domain. But usually malicious or suspicious IOCs will have less popularity records in this data source. And we can use this is quite efficient and simple metric to filter out false positives most of the time, but not always. The last data source is internal data source we have in Cato is security incidents. As you remember before, we see this page when we saw the threat intelligence used in the XDR product. So that's it. We actually can see in our internal records how each IOC has been used in security incidents in the wild. And if we find that potential IOC appears in multiple security incidents, it may indicate that this is a real IOC and it's a true positive, and we should continue to block it. So we mentioned several times before the machine learning model. So let's deep dive into what is this machine learning. As I said, this is the second layer. After we filter the IOCs, we want to get a bottom line score. So the data sources of this machine learning model is, we have many kinds of data sources. This is actually most of the time it's third parties that their input is just the IOC, let's say the domain name, and the output is generally a big JSON that describes many aspects of this IOC. In case of domains, it can be the registration date or registrar or many other details about it. We take all of this information together, convert it to a numeric vector. Machine learning most of the times is comfortable to work with numeric vectors. After we convert it to a numeric vector, we feed the machine learning model, which in our case, let's guess, it's a random forest, which we find is the most plug-and-play model for such cases. The model output is just a 0 to 1 verdict about the maliciousness of this IOC. Once we have this maliciousness score, we publish based on the verdict. If the model finds it as malicious, we publish it to production, and for blocking if the customer tries to access this. So far, we talked about the machine learning, the whole of the pipeline until the machine learning model. We got all of the IOCs that passed the filters. They went to production, to block mode. Now we are talking about the reverse process of the feedback. So as we see, our random forest model made a verdict about an IOC, and now we are going to the field feedback. So the field feedback, I'm going to talk about 3 kinds of feedbacks. The first one is the popularity. We already mentioned it. Popularity, how many blocks. If I find this IOC is malicious, I can count how many blocks we find. If we find that many customers and many hosts were blocked on this one, sometimes it's it may be a kind of alert, of alarm, because, most of the time malicious or suspicious IOC, they are not blocked so much. So that's a simple metric, can tell us where we stand. And the second one, we already talked about it, just mentioned it, security incidents. How many security incidents we found with this IOC? Because the security incidents contains much more than just popularity, it contains actual exploitation attempt. So if we see that this IOC was involved in many exploitation attempts, we get a green light that maybe we are in the right direction and this IOC should be continued to be blocked. And the third one is the most painful, user complaints. User can complain, why did you block me this IP address? It's not malicious, I use it generally in my organization. User complaints or escalations we get on a daily basis, and we tune our pipeline according to that. And the last one, which we are going to talk about extensively, is the IOC fit score. As we mentioned before, we don't get IOC by one. We actually get lists of IOC. And generally, these lists are generated by the same persons, same organization, and evaluating these IOCs list together generally tells us what is the quality of this source. So we just going to explain how we calculate this feed score. We get sometimes we are paying for a third-party source about getting its IOC. We want to understand what is the quality of this one. So I'm going to talk about 6 metrics which we find that tell us if an IOC feed has high quality or not. The first one, maybe the most simple one, is freshness. If we have a great feed but which are updated once in a month, it's nice, but it's not enough. We want to be, as I said, we want to be very responsive with the feed. We can't wait so much. We want a source that is updated on a daily, even hourly basis. The second one is popularity. If I have an IOC feed that contains many, high popularity domains, it's an alarm. I may suspect that this feed has many false positives, and I won't pay for that. The third metric is actually you may understand, we have a manual allow list indicator, because when customers complain, we usually insert the IOCs in their complaints to an allow list. So if we are trying to integrate a new threat intelligence feed and we see that many of the IOCs in this feed appear in the allow list, I may say, oh, these feeds are going to make us many troubles. Let's not pay for that. The fourth metric is overlap. Overlap is a bit tricky. Overlap first is how this feed overlaps with other feeds we already know. So this is an interesting metric, because if we have a feed that correlates or overlaps massively with other feeds, 90%, for example, I say, okay, what is the additional value of this feed? Why should I pay for that? I already covered it in other feeds. So that's on the one side. On the other side, if we have a new threat intelligence feeds that doesn't have any overlap with any other feed, it's quite suspicious, because usually feeds has even a few percents of overlaps with other feeds, which give you a sense that this feed is thinks the same, or try to cover the same IOCs usually. So I would say that the overlaps should not be 100, but also should not be 0. We want it somewhere in the middle. The 5th metric I'm going to talk about is the security incidents. As I said, if this feed helped us to find many security incidents, it may indicate that it has high quality, and it's a good ROI for this feed. And the last metric is total item count. Here, like freshness is quite simple, because I won't pay for a feed of 10 IOCs. I want generally a few thousand at minimum, and generally the feeds are have much higher scale, like a few millions. So it's something I should I feel good about paying about this. So we talked about the machine learning feedback. Now, once we get the feedback, one of the first questions we should ask is, should we retrain or fine-tune the model after every few days or week? So generally the answer is yes, but this process of retrain the machine learning, the random forest model, has some pros and cons. Let's touch it quite shortly. The pros, I think it's quite straightforward. We got feedback from the field. We have additional data. We want to retrain the model, which can improve our results. Less complaints from the field, less complaints from the customers. Sounds good, no? And our precision, accuracy, all the metrics should be improved. But this process also have some cons. The first one is resources. Retraining the model from scratch requires resources, of course, cost, etc. And the second thing, I think is the most, it's even more important, is the overfitting. If this week I got some feedback from the field, but this feedback, finally people are making this feedback. If this feedback contains some misleading information, like misclassification of IOCs, like as benign or as malicious, what I'm trying to say that it may poison our model with wrong data, and this is production model. So if we poison the model, it has severe results on our performance in production. And of course, it's time consuming. This training doesn't take 1 minute. The whole process also requires a data scientist that will do this retrain, but also it takes several hours, usually, to prepare the data, to make everything. The training itself also takes time. So that's for fine-tuning the model. The next, we are going to talk about, from our experience, 3 things that once we have that threat intelligence system, we want to talk about several conclusions we got during the process. The first one, always use the automatic filtering. We build that system. This system filters out every day millions of IOC, which it finds as false positives. So 99% of the false positives are filtered by this automatic mechanism, so it's great. Another thing is metrics. We strongly advise that everyone that build that system will have some metric to understand how it performs in the production. How many complaints we have from the customers, how many filterings we have. If one day we see that we have tons of filterings by the system that is much higher than in general, it may indicate that something went wrong. And the final conclusion, which is always true, is always to have some manual verification on the data. Usually we want to have some analyst or someone that checks from time to time the data that the system outputs to see we are okay, we are aligned, we didn't, change things too much. Now we are going to go over shortly about on the architecture of our system. On the left, we see the IOC feeds. Just an example, we have hundreds of IOC feeds. Each of them has millions of IOCs. Next, these feeds are flowing through the scraping manager, to fetch feeds. We usually build scrapers. After it goes through this scraper, we still have a list of many IOCs. We are in the enrichment level. So all of the IOCs going into a queue, and then the TI service is fetching each of these IOC and enrich it with many other third parties, the third parties we talk about. So for every IOC, we get a huge JSON that tells us actually everything we can know about it, where to which servers it relates, when it was registered, anything we can get. After the data augmentation we do with the third parties, we are going into the random forest model we talked about. And this random forest model outputs the verdict we talked about, and the 0 to 1. According to this verdict, we understand if it goes to block in production or not. And then we also, of course, saved this information in the DB we have. We don't want to lose it. We paid for it. We invested the effort in it. And also it go to block in the production environment. And from the production environment, as we said before, we finally get feedback from the field and, fine-tune our model, or that we understand that this should be entered to the allow list and we should not block it anymore. So far, that was our architecture. Some thoughts about future enhancements to the world of tips. So the first one is enhanced contextual analysis. Some big words. It's kinds of, I think that so far we talked about IOCs in quite a static environment. Every IOC is, it's quite binary. I can block it, either allow list it. But IOCs, many times we also want to understand the propagation process of an IOC in the network. Let's say on the Sunday I saw this IOC in 2 hosts, but 1 week later all of the network started to use it. So seeing this propagation process can tell us a lot about this IOC. It also can help us to understand some lateral movement, maybe if it's a malicious IOC. The second possible enhancement is collaborative tips. So we introduced our tips, but as you know, there are many other tips in the world. Some of them you even can purchase. So why not to make a committee of tips to get a better conclusion of all of the tips together. And the first one is actually a kind of autonomous tip, or something that rank the IOCs, give it a more, rank them according to their maliciousness, and maybe, the top 10% we are blocking, and the rest we are have another directive, things like this. That's all for today. We actually talked today about the feedback loops in our tip, the architecture of how we build our tip in Cato. And we talked about some possible enhancements and what the future of TIP can be. And thank you very much for today.
No? Yes, now. Awesome. Thank you very much. It was a very interesting talk. We do have a little time for questions. Any questions in the room? Rado is going to provide the mic.
Hello, thank you very much for the talk. I have one question regarding timeliness. So one of the challenges is, for example, for an indicator like an IP address, that it's now a malicious IP, and in 15 minutes it might not be a malicious IP anymore. How do you handle that?
So actually that's a very good question, because we encounter it several times. So what we found, that blocking IP in general is each match is much more complex than blocking anything else. What we do most of the time, we block together the combination of IP and the domain. So but that's in the case of shared hosting. Most of the times we want to detect that this IP is shared across multiple domains, and generally we won't block this IP, just trying to block the communication by other IOC types, domain or anything else.
One quick question, maybe?
Hello. Yeah. If our customers are not interested to invest more on the GPUs and machine learning, for such customers, do you have any suggestions for achieving this in a cost-effective manner?
You mean that if training the model is cost-effective for the blocking? Actually, yes. This machine learning model saves us many. Generally, since it's based on dozens of features, it's quite accurate, and yes, we found it very cost-effective and very also easy to train, easy to build this pipeline, because we use very straightforward features which are available for us, and training the model is very straightforward because it's very simple. It's random forest. So yes, we strongly recommend to adopt this option.
Okay. Yeah. Thank you.
And that's it. I heard that you are around here, so for any further discussions.
Okay.
Thanks again.
Thank you.